Tesla's Giga is not just a factory. It is the epicenter of a technological renaissance that is redefining the future of mobility, robotics, and industrial sustainability. At the heart of its quiet revolution lies one of the most important breakthroughs in modern manufacturing, the 4680 battery cell. This innovation doesn't just improve performance, it rewrites the very economics of electric vehicles, EVs. These batteries charge faster, live longer, and are constructed with fewer parts and materials, yet produce greater energy output. This efficiency is not a small improvement. It is a foundational shift. For decades, batteries were one of the most expensive and limiting components of EVs. But now, thanks to the work being done at Giga, production costs are plummeting while capabilities soar. The long-awaited promise of affordable, high-performance EVs is no longer a dream. It's being built cell by cell on the Giga production lines. This affordability isn't simply a matter of market penetration. It's a wake-up call for the entire automotive world. For companies that once considered Tesla a boutique brand for the elite, this shift spells trouble. With high-performing EVs becoming more accessible, the traditional pricing advantage held by legacy automakers is dissolving rapidly. Giga has become a factory of disruption. It's not just building cars, it's building systems, robots, batteries, and platforms of intelligence. Vehicles assembled here are no longer just machines. They are evolving data entities that learn, adapt, and update over time. Imagine a place where 2 million vehicles can roll out each year. Vehicles that are not only electric but also increasingly autonomous, sustainable, and hyper-efficient. That's the scale of ambition being realized inside Giga. It's not just about speed of production. It's about a new class of production, where AI and robotics work hand-in-hand with human ingenuity to push the limits of what a factory can do. This facility has transcended its industrial roots and become something else entirely, a robotic city. Algorithms hum beneath the concrete, sensors whisper through the walls, and every second, data pulses like a digital heartbeat through the factory's veins. Tesla has done something no other automaker has done at this scale. They've turned a manufacturing plant into a living organism of innovation. The ripple effects are global. Companies like Ford, GM, Toyota, and Volkswagen are scrambling to rewire their decades-old supply chains and rethink what production even means. Because Elon Musk hasn't just set a new standard, he's set a new philosophy. Tesla doesn't iterate slowly, it innovates boldly. With Giga, Musk has shown that building a car can be as scalable and fluid as deploying software. The traditional boundaries between design, testing, production, and delivery have blurred. Each vehicle is born not just from parts and labor, but from an ongoing stream of intelligent updates, responsive systems, and predictive analytics. This is why Tesla isn't merely a car company, it's a platform company, and Giga is its motherboard. From this hub, Tesla aims to dominate not just EV sales, but also the energy grid, AI development, autonomous systems, and personal robotics. While legacy automakers are still discussing quarterly production targets, Tesla is scaling a vision. Every bolt turned in Giga echoes across global markets. And this is not marketing fluff, it's visible in policy shifts, competitive pivots, and new industrial alliances around the world. But the transformation doesn't stop at vehicles. The factory itself embodies a future-forward ethos. Unlike traditional factories filled with pollution and chaos, Giga has been designed to be sustainable from the ground up. Solar panels power large parts of the plant. Water recycling systems ensure minimal environmental impact. Green spaces are woven into the architecture, making it not just a symbol of human advancement but of environmental responsibility. Elon Musk's vision is clear. Sustainability isn't just a feature, it's the foundation. And then comes the most futuristic part, robots. Not just robotic arms, but humanoid machines like Tesla's Optimus. Designed, tested, and trained right inside Giga. Optimus is being prepared to take over repetitive, dangerous, or even domestic tasks. The work being done to train these robots to walk, lift, decide, balance, and even interact might seem like science fiction, but it's happening in real time, in a building that already looks like it was transported from a future century. Musk envisions a world where every home has a robot, much like every hand has a smartphone today. The trials have begun, the intelligence is evolving, and the price is expected to fall with mass production. Just like EVs, just like solar, just like data plans. So what is Gigatexas? It is not a car factory. It is a frontier, a technological outpost from where the next era of human-machine collaboration is being charted. It is where the boundary between physical product and digital intelligence vanishes, where vehicles no longer run just on electricity, but on real-time data, where factories don't simply assemble, but think, adapt, and evolve. And when people see the Teslas of tomorrow, cheaper, smarter, cleaner, they won't ask where they came from. They'll know. This isn't just a product of Austin, Texas. It's a product of tomorrow, born in steel and circuits, nurtured by algorithms, powered by the sun, and driven by a vision that the future doesn't arrive on its own. It is built, and it is being built right now, every second, inside Gigatexas. But even as Gigatexas shapes the future of production, Elon Musk has introduced something in the EV market that has shaken up the entire auto industry. While companies were focusing on speed, range, and luxury, Musk turned his attention to something most ignored: the motor. That silent, efficient machine beneath the floorboard, often unnoticed, has now become the epicenter of a new revolution. Tesla has introduced a motor that is not only more powerful, but also more durable, efficient, and critically, less expensive. And it does all this without heavily relying on rare earth materials. This change is monumental. In an era where sustainability and scale are just as important as speed and style, Tesla's new motor marks a leap toward a more balanced EV future. It's not about gimmicks or hype. It's about a fundamental rethinking of how electric cars move. This innovation is Tesla's subtle yet powerful reminder that real progress isn't always loud. Sometimes it hums quietly beneath your feet, driving you forward while the world plays catch-up. Musk's approach rewinds us to the vision of Nikola Tesla himself, the pioneer of alternating current, who believed electricity could change the world without noise, smoke, or destruction. More than a century later, that dream is reborn in this new motor technology. It represents not only a technical breakthrough, but a philosophical one. True innovation, Musk shows us, doesn't clamor for attention. It commands it by sheer performance. This new generation of Tesla motors, first seen in vehicles like the Model 3, uses permanent magnet synchronous reluctance technology. Built with efficiency in mind, it reduces energy loss, increases torque, and requires minimal maintenance. These motors are intelligent. They regenerate energy while braking, stay cool under high performance, and deliver power instantly. This is not just engineering, it's art. With these motors, Tesla is removing yet another barrier to EV adoption. Better motors mean lighter cars, longer range, faster acceleration, and lower costs. And with less dependency on rare earth magnets, they are also less harmful to the planet. It's the kind of innovation that doesn't just push Tesla forward, it drags the entire industry with it. So while headlines might focus on self-driving, AI, or flashy Cybertrucks, the quiet revolution in Tesla's motors might be its most transformative leap yet. Because inside every great machine, it's the hidden power that truly drives the future. And in Tesla's case, that future is already spinning, silently, efficiently, and with relentless purpose. Now here's the fascinating part. Tesla didn't just improve its motor with new hardware. It fused intelligence into the very core of the machine. Yes, this motor runs not just on electricity, but on software-driven intelligence. You could say it's not just a motor anymore, it's become a thinking device. But how does that even work? Let's break it down. In regular city driving, where you're stopping at red lights, inching through traffic, or accelerating from a standstill, the motor automatically switches to torque priority mode. This means it produces more pull so that the car feels instantly responsive. No delay, no lag, just instant acceleration that feels smooth and powerful. But as soon as the car hits the highway, the software senses the change. The motor then switches to efficiency mode. It reduces the unnecessary torque output and prioritizes lower energy consumption. This not only extends the range but also reduces stress on the battery. All of this happens seamlessly in real time, without the driver ever noticing. Behind the scenes, advanced sensors, smart software, and real-time magnetic field adjustments are orchestrating everything. This kind of dynamic performance optimization is not possible with traditional mechanical systems alone. It's the result of years of algorithmic development, where engineers taught the motor how to think, adapt, and respond to changing conditions, like a brain inside a machine. The result? A Model 3 that is not only lightning fast when needed, but buttery smooth when cruising. It sips electricity more wisely. It's quieter. It's cooler. It puts less strain on the cooling system and, most importantly, it preserves the battery for longer life. The motor itself is also lighter now. With fewer moving parts and a compact design, it reduces the overall vehicle weight and improves handling and range. But the most impressive part? Low maintenance. Since it has no traditional wearing components like brushes or gears, it demands little care. It doesn't break down easily. It doesn't overheat. It just works. So, naturally, you might ask, if this motor is so groundbreaking, why did Tesla roll it out so quietly? The answer lies in Tesla's philosophy. Innovation is not a showpiece. It's a necessity. Unlike some companies that hype every new release with flashy marketing campaigns, Tesla tests its technologies rigorously in real-world conditions. Only when they are truly ready, only when they pass the toughest internal benchmarks, do they reach the production floor. The upgraded motor in the new Model 3 is not a marketing gimmick. It's the result of relentless iteration, deep thinking, and the willingness to redesign something old into something extraordinary. And behind this motor, there's a hidden hero, neodymium, the supermagnet. Neodymium is no ordinary material. It belongs to the family of rare earth elements and possesses magnetic strength far superior to typical metals. This tiny powerhouse allows the motor to be small, yet incredibly strong. It's what gives modern EVs their quick acceleration and their silent, smooth performance. Every time you feel a Tesla surge forward effortlessly or glide at high speeds without vibration, you can thank neodymium for making that possible. But with great power comes a great cost. Neodymium, as its name suggests, is rare. It's not easily found, and extracting it is both difficult and dangerous. Mining it requires massive open-pit operations, harsh chemicals, and vast quantities of water. This causes environmental damage on a scale that is often hidden from the consumer eye, rivers polluted, soil poisoned, and health hazards for communities living nearby. But the danger doesn't stop at environmental damage. There's also geopolitical risk. You see, the majority of neodymium comes from one source, China. This gives a single country enormous control over a globally critical resource. If China were to limit exports or raise prices, the entire electric vehicle industry could face a crisis overnight. Imagine the consequences: production delays, skyrocketing costs, global supply chain chaos. Tesla saw this risk early, and they began working on an alternative that's not only safer for the planet, but also immune to political manipulation: ferrite magnets, also known as ceramic magnets. Now, ceramic magnets aren't new. They're used in everyday devices like speakers, refrigerator doors, and electric mixers. They are made from iron oxide, essentially rust, combined with abundant and cheap materials like zinc and manganese. They are safe, stable, and globally available. But they come with one big drawback: they are weaker than neodymium. So why would Tesla consider downgrading the motor's core component? Because instead of relying on brute magnetic force, Tesla engineers asked a better question. What if we let the motor rely on smart design instead of just power? The answer was a radical shift in motor architecture and algorithmic control. By optimizing the layout of coils, refining current flow, and precisely placing even weak magnets, Tesla created motors that could match the performance of rare earth-based designs, using smarter software instead of stronger materials. This approach is not about making just one good vehicle. It's about preparing for a future where Tesla deploys millions of cars, especially autonomous fleets that operate globally 24/7. Scaling production for that kind of future cannot rely on rare, expensive, and politically unstable resources. It needs something scalable, affordable, and sustainable. Ceramic magnets check all the boxes. Even more importantly, these magnets can't be monopolized. They are available everywhere. No country can weaponize them in trade wars, and their extraction doesn't poison rivers or forests. In other words, it's not just about Tesla making smarter motors, it's about building a smarter planet. What's inspiring is Tesla's quiet commitment. The company isn't bragging about inventing something new. It's doing something far more impressive, taking something old and making it brilliant. It's honoring Nikola Tesla's original vision from the 1800s, a world where machines run cleanly, silently, and efficiently on electricity, without smoke, noise, or combustion. Nikola Tesla once introduced the concept of the AC motor. At the time, it was ignored, laughed at, and dismissed. But Elon Musk's Tesla took that ancient design, understood its potential, and redesigned it using the tools of the 21st century: sensors, software, rare earth-free materials, and AI-based control algorithms. That's not just innovation. That's resurrection. So when you see a Tesla glide past you without a sound, remember, it's not just a car. It's not just a motor. It's a philosophy in motion. Proof that the biggest revolutions don't always start with noise. Sometimes, the quietest machines bring the loudest change.